week we need to cover a few kind of little bits of topics, so it's a slightly mishmash week, I'm afraid. But it's the end of what's called the multiplicative reasoning chapter. So for those of you taking wonderful notes, this will finish off our notes for the multiplicative reasoning chapter. Then we'll move on to, I think, a little bit more trigonometry. Been a while since we looked at any trigonometry, so that'll be fun for the coming weeks. But today we're going to look at things that I've split into two categories. So to start with, we're going to look at speed, density and pressure. Now you might have done this in science or in maths previously. We're just going to look at 3 triangles, and then I'm going to just give you some questions to have a look at. This is a nice break in comparison to what we did last week. You'll be familiar with speed. Speed equals distance over time. Now, jury's out about the triangles. I don't see anything wrong with them, providing you set your work out nicely underneath. So I'm going to draw the 3 triangles that we're going to be talking about today. Now, from my experience, and definitely when I was at school, science didn't like the triangles. So it might be that you're taught a couple of different methods, but I think I'd like you to just learn these 3. If you know these 3, you'll be absolutely fine. Trying to make these 3 triangles the same size without measuring or counting. Has that worked? Who knows? Maybe. Right. So what have we got? We've got a speed triangle, we've got a density triangle, and we've got a pressure triangle. So, hopefully you're familiar with speed, distance and time. Hopefully that's familiar. You might want to label that speed, distance, time. This one in the middle is going to be density, mass and volume. So density equals mass divided by volume, and then we've got pressure equals force divided by area. So let's just label those. So we've got density, mass and volume, and we've got pressure, force and area. So looking at this pressure, it's the force divided by the area. Now this explains why if somebody stands on your foot with a normal shoe, it's not so bad. But if someone stands on your foot with a high heel, it's the end of the world. It's because if you think about pressure, it's the pressure that your foot's feeling. A big area, you're dividing the same force by a big area, so the pressure is going to be a bit smaller. If I've got the same force divided by a small area, then we're going to have a lot of pressure. So that explains, to some extent, why people that stand on your foot wearing high heels, why that's a bit of a disaster. And I can't not label this one. So we've got speed, distance, and time. Right. I'm not going to talk about speed. I think that's probably fine. Just be really, really careful with the units. Yeah, it might be meters per second. It might be kilometres per hour, and you need to be happy converting between them. Also, make sure you're happy with the fact that is the same thing. So meters per second with a slash, or an m and then a second to the -1. Now you know that's the same thing. You know that a power of -1, the minus puts it on the bottom of the fraction, so over, and s, the power 1 just means we're going to have just an s. So that makes sense. Yeah, it all ties in. So I could write this as kilometres per hour. You just need to be aware that they're the same thing. The only thing I am going to say is you need to be able to convert between, say, like 60 kilometres per hour to metres per second. They like conversion questions like this. So I would set it out really, really logically. So I would write that this person does 60 kilometres in 1 hour. So we eventually want to get to metres per second. So I'm going to write this as minutes. So he does 60 kilometres in 60 minutes. Yeah, I haven't actually done anything. I've just written that 1 hour is 60 minutes. Now I'm going to, I guess, get down to 1 minute. So I'm going to divide both sides by 60. So he does 1 kilometre in 1 minute. Now, I want meters and seconds. So why don't we not actually do anything, but write these in meters and in seconds, like that. Right, and I want, what do I want? Meters per second. Well, I've got meters and seconds, so I want per 1 second. So I've divided that side by 60. So divide that side by 60. She says, trying to find a calculator. So 1,000 divided by 60, which gives me 16.7 meters, which would be 16.7 meters per second. So that speed and 60 kilometers per hour are the same thing. You just need to build it up systematically. Never try and do it in one jump. Okay. So that's speed. Now let's look at the middle triangle, which is density and density. So our middle triangle is density, mass, and volume, like that. Okay. So let's try and find the density of, I don't know, let's say we've got a gold bar. Let's say it's 300 grams, and let's say the volume of it is 30 cubic centimetres. And we want the density of this gold bar. So we do that density equals mass divided by volume. We can get this from the triangle. We want density, we're left with mass over volume, which is 300 grams divided by 30 centimetres cubed, which is 10. Now, our unit for density, you need to build your unit based on the amounts given to you in the question. So we did, the mass was in grams, so we did grams and we divided it by centimetres cubed. So our volume is grams per centimetre cubed. Okay, that's our unit for this density. And your unit might be different. Had that been kilograms, we would have kilograms per centimetre cubed. So density, you can't just remember what the unit is. You just need to remember to build it each time. So whatever you did divided by whatever. Now, sometimes you're given the density and the volume and you want the mass, and you can see from the triangle they're on the same level, so you'll just multiply them. It works the same as it does in the speed, distance, time situation. Okay, right, the last triangle that I want to look at then is pressure, force and area. So let's say I've got a force of 25 newtons. Now, force is always measured in newtons. Okay, so you just need to remember that. And then our area could be, I don't know, 10 meters squared. And again, pressure, the unit, we're going to build it. So pressure is going to be force divided by area, which is 25 divided by 10, which is 2.5, and I did newtons divided by meters squared. So newtons per metre squared, we would say. We could write it like that. Either of those is fine. So newtons per metre squared. And again, that will change based on the question. If I want area, I would do force divided by pressure. If I want force, I do pressure times area. Okay, so they're the 3 new triangles that I'd like you to be aware of. I'd also like you to be aware of a couple of other formulae which come up a lot at A level, but which seem to kind of make a little appearance now. And they're what you call the kinematics formulae. And again, this is all part of this multiplicative reasoning chapter. I'm going to put the textbook pages up so you can try some questions. I think that's probably the easiest thing to do. So kinematics just means kind of moving. Like kinetic energy. Yeah, that means kind of energy that happens from movement. So there's just 3 that we're going to look at. Now, you don't need to memorise these. You just need to be I just want you to be familiar with them, because sometimes they ask you to rearrange them or to use them, and I think it's important that you've seen them and that you have some understanding of what these letters stand for. So we've got V equals U plus AT. We've got S equals UT plus a half AT squared. Now don't panic when I explain these, and again, you don't need to remember them. You just need to have seen them so that they're not a complete shock if they ever do crop up. So we've got V equals U plus AT, S equals UT plus a half AT squared, and V squared equals U squared plus 2AS. So V is just velocity. So remember that velocity is like speed, but it's allowed to be negative because it takes direction into account. So if I was walking forwards, I would perhaps have a positive velocity, and then if I were to go backwards, my velocity would then be negative. So velocity is allowed to be negative. U is your initial velocity, okay? So it's the speed that you started out at. So if you were stationary, it would just be 0. If you were driving at 30 kilometers an hour, it would be 30 kilometers an hour before the event happened. A is your acceleration, which is measured in things like meters per second squared. So it's, or kilometers per hour squared, but meters per second squared is the most common acceleration. It's the rate of change of your speed. So it's how your speed is changing per second. So it's meters per second. So meters per second squared. And what else have we got? T is time. And then we've also got S, which is what we call displacement, which again is just a posh word for distance, but you define some direction. So your displacement could in fact be negative. So in an exam, you would have to perhaps decide which of these equations to use. So you'd be given some information and you'd have to decide which one is going to be most useful. Okay, so let's just have a look at an example. So I might be told that I'm starting out, I'm not moving, I'm stationary. So I'm not going anywhere. My initial velocity is 0 meters per second. I might be told that my acceleration is 5 meters per second squared, and I'm travelling for 10 seconds. I want to know how far I've gone after those 10 seconds. So remember, your S is your displacement. So I want to know what my displacement is after those 10 seconds. I start not moving, and then I'm accelerating at 5 meters per second squared for 10 seconds, and I want to know how far I would go. You need to pick the equation that fits. So I've got a U, an A, and a T, and I want an S. Well, that doesn't have an S in it, so I can rule that one out. That one doesn't have a T in it, so I can rule that one out. This is the one that I'm going to be using. Okay, so let's write it down. So I've got S equals UT plus a half AT squared. So S equals, well, it's 0 times 10, so that bit's just going to be 0. And then I've got a half A times T squared. So I've got half times 5, which is 2.5. Remember, times means of. So a half of 5, 2.5 times 10 squared is 100. So 250 meters. So if I started, it's in meters because my acceleration was meters per second. So if I started not moving and I accelerate at 5 meters per second squared, for 10 seconds I would do 250 meters. So they're quite clever formulae. Not overly realistic. In real life, your acceleration is rarely a constant, but for maths, certainly at A-level we refer to these as what we call the SUVAT equations, because it's got SUV, A and T, so we tend to call them the SUVAT equations. I just wanted you to be familiar with them. They are alluded to in the textbook very briefly. So I think that is all the waffle you need to be able to have a go at 11.2 and 11.3. So 11.2 and 11.3 are on Show My Homework. I think that is the end of Chapter 11, Unit 11. Now my thinking is that we'll save the unit test and we'll use it as just a revision sheet when we get back to school to refresh our memory. I don't want you doing loads and loads of tests at home. So I'm going to keep it and we're going to use it when we get back to school as like a revision sheet to refresh our memory. Okay, so I'd like you this week to have a look at 11.2 and 11.3 and I'll upload the answers. But as always, send me any questions, any photos of notes or any photos of work. You're working absolutely brilliantly. I miss you lots and I can't wait to have you back in my classroom.